So I'm going to give you 3 different types of problems tonight. The first part is just vocab. So with these 3, I'm going to throw in one more. Next slide. Actually, I'll put it down here, constant. And this is where you want to take notes on the paper you got out. Yeah, whatever you need to write down. So here we go. Terms. What are the terms for this expression? Remember, this is expression, not an equation, because it's not an equal sign. No equal sign, then it's expression. Terms. This has 4 terms. Okay. They are 2, 3x, negative 4y, and 5z. So you could write a definition if you wanted to, like, okay, term are separated by adding, subtracting signs, but just have a way of knowing, well, there are 4 terms here, here's what they are. Most common mistake is saying that the term is 4y instead of negative 4y. Remember, a subtraction sign and a negative sign are the same thing. When you guys are learning subtraction in 2nd grade or 1st grade, like 8 minus 3, not on the graders, that's the same thing as 8 plus a negative 3. Subtraction and negative are the same thing. I'm just going to call it negative when you first learned it, but it's the same thing. Factors. What are factors? All right. So okay. So 3 and x are factors because they're being multiplied. Negative 4 and y are factors being multiplied. The same thing with 5z and 5 and z. When being multiplied is like a factor. A long time ago, you guys did this with like numbers. You'd take like 6, and you'd say, okay, there's number 3. That's 2 times 3. 2 and 3 are factors of 6 because they multiply equal 6. So same thing here. It's just one of them is a variable. Same idea. So that's factors. Technically, we could say 2 is a factor because we could say this is 1 times 2. So 2 can be a factor as well, but we usually, even though it might be, or if you don't really pay attention to it, we're talking about factoring. Okay? Meaning, if it's 2, rarely do we say, okay, that's the same as 2 times 1. Like, well, you don't need to state the obvious. So that's factors. Coefficients. I'll write them down. You come up with what definition is. I already know, but it's good with you. Coefficients for this expression are 3, negative 4, and 5. So, given that, what is the definition of a coefficient? Use the context of what's not there to help you out. Yep. Numbers in front of a variable, yeah. So on your notes, you might want to write that down, like coefficient, number in front of a variable, or something like that. Number in front of a variable. Now, constant, that's like the opposite of a coefficient. It's the number that has no variable. That would be 2. There's a 2 right here. Would be the constant. So think of coefficients and constants. A coefficient cannot be a constant, and vice versa. It's one or the other. So in real life, what do we mean by constant? Okay, so variables mean vary, right? It changes, it varies. Constant, something that's constant or consistent, does not change at all. No matter what x, y, and z equal, we plug in values for x, y, and z. It's always going to be plus 2. Plus 2. That doesn't change. It's constant with all the No matter what values we plug in, all of them are going to end up doing plus 2. That does not change. All right. Okay. You guys try, just do the top one. Write out the terms, the factors, the coefficients, and let's also throw in a constant. So how many terms, by the way? Great. 8p, 2q, 7r. And they're all positive at this point. The factors are 8p, 2q, and 7r. The coefficients are 8, 2, and 7. And the constants are? No, there are no constants. Every term has a variable. So to solve this, you just have to be given what p equals, q equals, and r equals, and then plug it. Got a good. So that's level 1. Level 2, I like these ones. So if you really know something, you can teach it, and you can find errors. So looking at this, let's say somebody so I had this problem. They said, oh, the terms are 9a, 4b, and 18. Can you find the mistake? What is Sally's mistake? Okay. A little higher level thinking, because you have to know, like, really know the definitions, to know how, what is and what is not. Yeah.
I'm supposed to make a 18.
Yeah. So once again, the most common mistake is, but that's a subtraction sign. Well, it's a negative as well. This is positive 9a, positive 4b, and negative 18. So don't forget that negative. After grading, algebra papers for 10, 11 years, whatever it's been, the negative missing is probably the most common mistake. So you do all the adding, subtracting, even show the work on both sides, but then at the end, forget a negative, forget to bring it down. So if your answer's ever not coming out right, that's the first place to go. Oh, what is the coefficient of b? Okay. 1, yeah. So we don't usually write 1b, but yeah. What about here? What's the coefficient of this? Negative 1, right? So true or false? Every variable has a coefficient. True. Yeah. Variable's there, it has a coefficient. So what I don't want you to do is say, oh, there's no number in front of the variable, so yeah, there's no coefficient. So whether it's written there or not, it definitely has. All right. That's the first part, just vocab, and can you find the error, tell me what the coefficients are. It's a good thing to warm up on. Second, can you read a scenario and tell me what different expressions represent related to the scenario? So go ahead and read this. Expo markers are like the markers that you use to write on the board in front of you or on the whiteboard below you. You can erase it, but you can call it. Supposed to be a permanent marker. So at the beginning of the year, we had to buy markers to use and erasers. So what does this represent? And what does 1.49x represent? So let's start off with this. What does 1.49 represent? Price. So that we take the units off in the expressions and the equations, right? But you have to know, even if we leave the dollar sign off, that stands for money. So a good way to start is the cost. Is this good enough? Is this descriptive enough? You're saying it's the cost? Cost of what? Cost of package of extra markers. And you have to write this out on your homework, test quizzes. Some of you are really not used to explaining yourself like this. Some of you learning curve for you. Others are just like, yeah, I always do. Same thing here. What does 0.99 y represent? Oh yeah, 99, that's cents, so that's the cost. You write it out. What does 1.49x plus 0.99y represent? Total cost. Yeah. Right. Not just total cost, because they're going to say, the question would be, total cost of what? Total cost of X goes to. That's what you need to do to answer these problems. Just like before with the other word problems, kind of talk about the units. We're not saying the dollar cost, we're saying cost. But okay, or if the tree is 15 feet, or you say 15 feet, well, what's 15 feet? The tree is 15 feet tall. Oh, it's the cost. What is the cost? The cost of the exposed. Okay. So, geez, there's two parts to all these explanations that we've done. Of course, proper capitalization, spelling, and punctuation is expected in every single class you ever take. There's always one person that says, we have to spell correct in math, spell correct in science. Yes, you have to spell correct always, everywhere. There's no time where you turn off your spelling or your punctuation. It's okay just to make up your own words. All right, go ahead and try this one on your own. Your turn. George buying watermelon, pineapple, for fruit salad. George buys fruit salad. He buys W watermelons. We don't know how many he's going to buy. $4 each, and he'll buy 2 more pineapples and watermelons for $5 each. So write down in words, just like I just showed you on your notes right now, what does 4W represent? Go ahead and write that down. $4W, what does it represent? Yeah, price or cost. Price of watermelon. And please do not take this opportunity to show laziness. Don't abbreviate, but WM for watermelon, you know. Do not go out of your way to do less than what you're being shown. That's what gets you in trouble with the grading. So you're being shown exactly what to do. I'm not abbreviating anything. Don't take it upon yourself to, oh, I'm going to do it this way instead. Okay. So we know 4W is the price of watermelons. What does W plus 2 stand for? What does that represent? Well, what is it? 2 more pineapples and watermelon?
2 more pineapples.
Yeah. That's 2 more pineapples and watermelon. So we know that this, W plus 2, stands for how many pineapples we're going to get. And then 5 times that, again, is the cost. So breaking this apart, when you read this, when you become good at algebra, when you read this, you're thinking this. This right here, this little part right here, says all of this. That's why math is so useful. You can say all this information in just this little bit. If you know, okay, this is watermelons. Okay, it looks like we're buying 2 more watermelons. It looks like the pineapples are 2 more watermelons. And it looks like the watermelons cost $4 and the pineapples are $5. This says everything that this does. And then we can figure out some more answers by solving them. So, yeah, once you become good, this and this will be the same thing. You don't look at this and say, it's 4W, and I don't care what W means. I don't care why this is W plus 2 and this isn't. You're going to understand and be thinking about that. And it's a whole different way of reading. All right, good. So, just so you know, on page 48, there are a bunch of, just reminder, like words that mean addition, subtraction, multiplication, division. Okay? So when you come by some words and maybe you don't know what they mean, like that means multiply, you can refer back to here, and that will help you out. At page 48. So right here. Price of concert tickets plus 12.5% service fees. So maybe you didn't know, like, there's percent. What do I do with percent? Is that like dividing? Do I just add? Go back to page 48. Where's percent on page 48? Give us back. No percents. No percents. There it is. Percent. So when I'm working with percents, you should be multiplying. So that's how I use that table. All right. So the price of a concert ticket. Price of a concert ticket plus, that's your sign division, right? Instead of writing out price of a concert ticket, let's just call the variable instead. Say P or T for ticket or C for concert, doesn't matter. Plus a 12.5% service fee. All right. What's 12.5? Now, do we ever have percents actually in equations? Ever seen percent signs inside equations? No. So, for step one, let's make this a decimal, right? So, how about use 0.25, right? Then, what do I do? Is that it? Right now, I mean, this is basically, what, 12 cents, 12.5 cents, 13 cents if I round this. Right now, what I have written is the cost of the ticket plus 13 cents, which is not what we want. We want 12.5%. Usually, when we use percents, it's percent of, and the word of means multiply. So we want to multiply this by the cost of the ticket. Meaning, if it was a 50% service charge and it was $100, what would the service charge be? $50. You would multiply 0.5 times 100, right? That's how you get the actual service charge. So you need to multiply that percent times whatever it is you're buying. So this is the same way you would do like tax. If you went somewhere to buy something, you'd say that the price, but then you have to add, okay, the tax, which is what, 8.5%, I think? You'd have to add 0.085%, right, of that item, and then add those two together. That would give you what it actually costs. So you guys know that the price on the shelf and the price that you pay at the register are different, and this is how you calculate it. So this is useful, especially since most of you people do not have credit cards or anything yet, right? So you only have $20 in your hand, and this item costs, let's say, $18.89. How do you know before getting up there in front of everybody that you have enough money to pay for it? Okay? This is how you pull out your phone and you calculate, okay, what would be the tax on this if it's 8%? That way you don't get in front of everybody and say, oh, I guess I don't have enough money. They're going to look at you like, well, didn't you figure that out before you stood in line for 20 minutes that you didn't have enough money? Like, that's what's kind of expected from society, and people look at you as a little bit less if you can't figure out you have enough money before you get up there. Not just go, oh, oops, I couldn't do basic math. You know, that's what you're telling the world. You don't want to do it. Okay? Figure it out ahead of time. This is exactly how you do it. Very real life. Okay? Same thing here. Let's say you had $40, right? And these jeans we're talking about are marked at like, let's see, they're marked at, let's say about $43, right? You only have $40. Do you have enough money if you have 30% off? how do you figure that out, right? Same idea. Of course, this is a discount, so this time it's going to be subtraction, right? You're going to take off that amount. But of course, also, if we include the tax, you still have to add the tax of 0.085. And this is how you figure out. Hopefully this comes out to be less than $40 because that's all I have cash. I'm not going to stand in line for 20 minutes and find out, oh, it's going to come out to $41.12 and I don't have enough money. Okay? So this is how you do this. If you only have cash and that's it, you're kind of close to that $4 amount. The nice thing is, these can be simplified. We'll subtract. What's 1 minus 0.3? No, 0.3, not 0.03. 1.0 minus 0.3. What does that equal? 0.7. All right, 0.7 plus 0.085. So 0.085, add it up. So we can say this is 785. 785. So this way, if you know, okay, it's 30% off and this much tax, all you have to do is take the price of the jeans and multiply it by 0.785 one time, right? And that'll give you whatever you have corrected. Now you do a lot more time then. Okay, let's do 0.3 times the price of the jeans. Okay, remember that answer. Okay, now let's do 0.085 times the price of jeans. Remember that answer. Now let's add them all up and see what you get. This way you can simplify and just put in 0.785 times the price of jeans, and you'll know how much it costs at first. That includes the 30% discount. Well, this is the original cost, minus the 30%, which is off 30%, so we added on the 8.5% tax. Right? So this is what people do regularly when they're shopping, trying to figure out how much things cost. Now, there will be a few people that just, you know, this right here is too difficult to do on the phone, and they'll just stand in line and figure out they don't have enough money. Or you can save yourself the embarrassment every time and just do it yourself. That way you know. And especially if you find out, well, that's a really good price. Maybe I get something else also on top of this because this is so much. Now, how much do I have left? And you can do this with multiple items. Right? So very useful to have. All right, you guys go ahead and try this one. Very similar. So it's good to understand how do you calculate this. So first you need, if you're going to pay 10% less, well, it's 10% less than what? Right? What are we starting with? 10% less than what? The house. So we have to start with, well, here's the cost of the house, and then take off our 10%, 10% of the house. So very similar to what we did here, where is the cost of the jeans minus 30%, so it's minus 0.3. But you have to start off with whatever your original price is. So cost of the house minus 10% of the cost of the house. Okay, price of the car plus 8.5% of the price of the car. Right? So price of the car plus, again, okay, there you go. Is that right?
Yeah.
Is this right? You sure?
Wait, what do we?
Is this correct there?
No.
What's wrong with it? Yeah, there's another 0. This right here means 85% sales tax. 1 0 makes a big difference. So when you move it, make sure you move it twice. Add a 0 if you need it. Yeah, there we go. Okay. And that will do it. Minimum day tomorrow, so it'll be a nice quick day.
Hey, how long was the period?